بعنوان عمر الهلال مركزي أم سطحي لعلي أكبر نيري. 10 دقائق فاضي إن شاء الله.
بسم الله الرحمن الرحيم. السلام عليكم. In the name of Allah, the topic of my presentation is Age of the Crescent, topocentric or geocentric. I work for the Calendar Center, Institute of Geophysics, University of Tehran. Well, there are different crescent parameters we should take into account to say if a crescent is visible or not. By now, you know much of them. Okay, these are the ones I want to focus on. Well, in this picture, we have sun and a crescent. And you see the elongation. It's the angular separation of the centers of sun and the moon. Well, for the same situation, for the same observation, I didn't change the situations, the circumstances. You see the delta altitude means the difference in the altitudes of sun and moon, which is 12 degrees. And here we have the difference in the azimuth of sun and the moon, which is 9 degrees. And this is the effective distance. This is a crescent at the perigee, means nearer to the Earth. I suppose it's some 356,000 kilometers from the Earth. And this one is moon at apogee. Well, contrary to what many people think, the elongation at the time of conjunction is not zero. That is a solar eclipse. If the elongation is zero, we have a solar eclipse. So at the time of conjunction, the elongation is not necessarily zero. And we know that an elongation of up to about 5.2 degrees is possible at the moment of conjunction. This is the formula for elongation and its relation to the difference in ecliptic latitude and the difference in ecliptic longitude of sun and the moon. This formula holds just for small angles. Can you see the moon? Can you see the crescent on the left of the image? Okay. Here we have both difference in latitude, ecliptic latitude, and difference in ecliptic longitude of sun and the moon. In this picture, sun, this is the moment of conjunction. Sun and the moon don't have any difference in ecliptic longitude, but they have difference in ecliptic latitude. That's the elongation. Well, what is age? Age is the length of time interval between conjunction and sighting moment. There is no ambiguity when we want to specify the sighting moment. There's no ambiguity. We can specify that in universal time, for example, and everyone understands. But for the moment of conjunction, should we consider it topocentrically or geocentrically? That's the topic of a debate. Well, what should we do to set a new record of age? What should we do? Well, different conditions should be prepared and should be met, different criteria should be met for a person to be able to set a new record of age. Moon should have a big enough northern or southern ecliptic latitude at the conjunction time. Because, if the moon starts from an eclipse, its elongation at the moment of conjunction is 0. It should start from 0 and reach 5.7, for example. If we accept the Danjon limit, it should reach 7.5 degrees. But if it has a big enough southern or northern ecliptic latitude, it can reach the Danjon limit sooner. So if someone wants to set a new record, it's better that moon have a big enough northern or southern ecliptic latitude. The second criteria is moon should be at its perigee near the conjunction time. Because when the moon is at perigee, it seems to us bigger, and also the speed of rotation of the moon around the Earth is higher, so it will reach the Danjon limit sooner. Then the observer should find the time at which the elongation is approximately that of the thinnest visible crescent, maybe the Danjon limit. That depends at when the observer is going to set his record. And the observer should find a place in which the elongation is mostly in the form of delta altitude, because delta azimuth will not help us much. If all the elongation is in the form of delta altitude, that's really better, because the moon is in those layers of atmosphere. You can sight the moon in those layers of atmosphere which are thinner. Well, those people who prefer topocentric conjunction argue the observer is not located at the center of the Earth, so why should we calculate the age geocentrically? The observer is not at the center of the Earth. That's nonsense, they say. Like many other parameters, the age should be calculated topocentrically. Why do you calculate other parameters topocentrically and just single out the age? The third, they say, why should we consider just one conjunction, the geocentric one, for all different observers? We have many observers around the world, maybe sighting a near crescent at the same time, around the same time. And why should we calculate the age geocentrically for all of them? Well, the people who prefer geocentric conjunction argue it's correct that the observer is not located at the center of the Earth, but the observer was not even located at his observation place, at his observation site at the moment of conjunction. The geometry of Earth and the moon has changed dramatically. Those other parameters are reckoned at a specific moment. For example, delta altitude, delta azimuth, the width of the crescent, the elongation, things like that. Those other parameters are reckoned at a specific moment, but the age is not calculated at a specific moment. It's an interval of time. It's the length of an interval. And geocentric conjunction provides us with a common origin for calculating the age. It's a common basis. So the question is, which one, the geocentric or topocentric age, which one is practical under diverse circumstances? If angular velocities change, the angular velocity of the rotation of Earth around itself and the angular velocity of rotation of the moon around the Earth, if they change, no ambiguity is introduced in the geocentric conjunction moment. We still have a specified geocentric conjunction time, conjunction moment. But the same changes in the speeds, in the angular velocities, will introduce an ambiguity in the topocentric conjunction moment. Well, let's speak about the conjunction plane. What is conjunction plane? First, we're speaking about an ecliptic plane. It's a plane containing the orbit of Earth, as you know. And a conjunction plane is the plane perpendicular to the previous plane, to the ecliptic plane, and containing the centers of both Sun and Moon. In nearly 2 hours, the conjunction plane sweeps the Earth, because the Moon rotates around the Earth, and this perpendicular plane to the ecliptic sweeps the whole Earth in nearly 2 hours. Okay, for typical new Moon, these curves are the intersection of the conjunction plane with the Earth and mapped to a flat surface. You see, no curves intersect each other, so there is no ambiguity. The previous slide was for natural circumstances. The Earth rotates as it is rotating now. But if the Earth rotated 6 times as fast as it's rotating now, we do not need 6 times. We just need 2 times as fast for the ambiguity to be introduced. But in these curves, I've considered 6 times as fast because I wanted to show you just the results. So you can see that the curves, the intersections of the conjunction plane with the Earth intersect with each other, which means we have points on the Earth with different conjunction times. Well, okay, I suppose I have more time because my original time was 20 minutes, and the schedule tells me that I have more time. The previously... Okay, thank you. That's a chronology of 3 different observations which set new records. In 20th of January 1996, Jim Stam set a new record of both age and elongation. In 19 August 2001, a group of Iranian crescent observers, of which I was a member, being led by Mr. Alireza Mowahed-Nejad, broke the record of elongation, but they didn't succeed in breaking the record of age. And in 7 September 2002, another group of Iranian observers, led by Mr. Mohsen Mirsaid, broke both the newly set record of elongation and Stam's record of youngest observed crescent, if we calculate the age of the crescent geocentrically. Okay, which method, geocentric age calculation or topocentric age calculation, which one is practical for sorting the records of age? Well, in different observations of the same crescent, the observation with the least geocentric age has actually occurred sooner than the other ones. But if we calculate the age topocentrically, someone who has actually seen the crescent later may have a better topocentric age. So he will set the new record. I'm going to introduce a fictitious competitor for any observer. At any instance of time, for every observer on the Earth, you can find a fictitious competitor for whom all observation-related parameters of the Moon are the same as for his counterpart at that specified moment. And to be illustrative, so just let me show the result of this. The final results. I will skip the details. Okay. This is Mr. Stam's observation. You can look at the different parameters of sun and the moon, and we can find a fictitious competitor for him in this example. I call him Mr. Stam's twin brother. You can see location of Mr. Stam is Tucson, Arizona, and this is what he saw, a simulation of what he saw. This is Stam's twin brother. You can see the location is Smithers, British Columbia, Canada. And the other observation-related parameters are the same. Everything is the same. Everything related to observation is the same. You can check. All the numbers are the same. And, well, excuse me, I will finish just in a moment. Okay, let me just conclude. Okay, if we calculate the age topocentrically, Mr. Stam's brother will set the new record. Even though they have seen the same thing at the same time, Stam's twin brother will be the record winner. Thank you very much.